All right, we're on to equilateral triangles. We are going to find side lengths and angle measures for triangles, and then we're going to classify them. Okay, we're going to prove theorems about equilateral triangles and apply properties. So you could probably do this in your sleep by now. But if we have an equilateral triangle, it has 3 congruent sides. Isosceles has at least 2 congruent sides, and scalene has none. Okay, remember that all equilateral are also isosceles. Next, we have the equilateral triangle corollary. Okay, a corollary is a theorem whose proof follows directly from another theorem. So we know that if a triangle is equilateral, well, then it's also equiangular. So what we know is that if we have these 3 congruent sides, if we have this, then we know this, that all of those angles are congruent. I almost said sides. Okay, so here is the equiangular triangle corollary. Guess what? If we know that a triangle is equiangular, boom, 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 if we know this information, okay, then we can say that the sides are all congruent. Okay, that it's equilateral, then the sides are congruent. All right, let's practice. So we have to find the side lengths for this triangle. Now, they've told me that it's equiangular because the sides, the angles are marked as congruent. So I'm going to use the equiangular triangle corollary. Equiangular triangle corollary. Okay, and I'm going to say that the sides are all congruent, so the sides have to be equal to each other. So I know that 3y minus 4 has to equal 2y plus 3. I can pick any 2 I want. I just need 2. Okay. Subtract 2y from both sides, and I get y minus 4 equals 3. Add 4 to both sides, and we get that y is 7. Okay, now I have to plug it in and find each of these sides. So if I found 7 and 7 was right, when I plug it in, I should get the same thing for all 3 sides. Here's hoping, guys. Okay, so let's start with GH. 2 times 7 plus 3. 2 times 7 is 14, plus 3 is 17. Okay, let's go to GH. Let's not use orange. Okay, GH. GF, I mean. Okay, GF. 3y minus 4. So 3 times 7 minus 4. 3 times 7 is 21. Minus 4 is 17. Oh, we're 2 for 3, guys. One more. Okay, FH. So 5 times 7 minus 18. 5 times 7 is 35. 35 minus 18 is 17. And the crown goes warm. The crown goes warm. Okay, so now we have to classify it. So we know a whole bunch of stuff about this triangle. We started off knowing that it was equiangular. Okay, because it was equiangular, because of this corollary, we were able to say that it is also equilateral. Okay, because all of the angle measures have to be 60 degrees because they have to be the same and they have to add up to 180, right? So it's also acute. Okay, lots of stuff about it. Flip. All right, we are going to find x and justify our steps. Hold on to your hats. Okay, let's start with our givens. Well, okay, we need our statements. Oh, shoot. We need our statements and our justifications. Okay, so let's list our givens first. So what do we know? We know that the measure of angle L, that's unfortunate, kind of looks like blah, blah, is 2x plus 32. Okay, what else do we know? We know, let me see if I can write that smaller. Measure of angle L is 2x plus 32. Okay. We also know that these sides are congruent because we have all these lovely little ticks. So we know that segment KL is congruent to segment LM, which is congruent to segment MK. And we know all those juicy little tidbits because they were given to us. Math presents. Okay. So, I know what else we know. If all of these segments are congruent, then we can say that this triangle is equilateral. Triangle KLM is equilateral. Equilateral. And that is because of the definition of equilateral. Okay, now that we know it is equilateral, we can say that it is equiangular. Triangle KLM is equiangular. And that is by the one we just learned, the equilateral triangle corollary. Triangle corollary. Corollary. Okay. Now that we know it's equiangular, we know that the measure of each angle of an equiangular triangle is 60 degrees. And there's no name for it. I just double checked. We just have to write that because that's a different corollary, but it has no name. The name is just the thing. The thing is the name. Okay, so we know that the measure of angle L, no, K, let's start with K, equals the measure of angle L equals the measure of angle M equals 60 degrees because each angle of an equiangular triangle is, or I should say, let's say measures 60 degrees. That was one of our corollaries from the triangle interior angle sum theorem. Because if they're all equal, then we just divide 180 by 3 and get 60. Okay, next. We know that the measure of angle L is 2x plus 32. So we're going to use this piece and make a substitution with our measure of angle L. So we know that the measure of angle L is 2x plus 32. So 2x plus 32 has to equal 60 degrees. And we know that because of our substitution property. Okay, next. We can subtract 32 from both sides, and we get 2x equals 28. That is the subtraction property of equality. I'm not going to make it. I'm just going to say POE. Okay, property of equality. Last, we divide both sides by 2, and we get x equals 14, and that was with the division POE. Ta-da! Okay, we did it. Don't worry that we have an extra line. Sometimes they just give us an extra one because I forget how to do it the fastest way, and I need an extra line. So it was just on there as just in case. Okay, next. Now we're going to do another flow proof. So instead of starting with the sides all congruent, we're starting with the angles all congruent. So we're going to have to use the equiangular triangle corollary. I'm reminding you as well as me as well as you, I mean to say. All right, so let's start with our givens. We're given that the three angles are congruent. Given. We're given that the length of ON or NO is 5y minus 6. That's given. And then the last piece of information is that the measure of OP is 4y plus 12. So OP equals 4y plus 12. Excuse me. All right, next. We are allowed to say that triangle NOP is equiangular because of the definition of equiangular. If all of the angles are congruent, we know it's equiangular. Next, we know that if it's equiangular, it has to be equilateral. And you can write this as equiangular triangle makes an equilateral triangle. Okay, so now we know it's equilateral. If it's equilateral, we know that its sides are congruent. So we know that NO is congruent to OP is congruent to PN. Okay, all of those sides, make sure you write them in segments. They're all congruent because of the definition of equilateral. Okay, now, because those sides are congruent, we know that their measures are the same. So we know that the measure of NO has to equal the measure of OP, and that's because of the definition of congruent. Okay, next. We have expressions for NO and OP. We know that NO is 5y minus 6, and we know that OP is 4y plus 12. So we can make substitutions using those expressions and have an equation to solve. So NO is 5y minus 6, and OP is 4y plus 12. That was thanks to the substitution property. Okay, next we have to, what did we do here? What did I do? Oh, I subtracted 4y from both sides. Okay, I got rid of the positive 4y, so I used the subtraction property of equality. Okay, last, it appears that I added 6 to both sides and used the addition property of equality. So that gives us y equals 12 plus 6 is 18. Okay, now I still have to plug that in to find OP. Okay, so my y is 18. Plug that in. Oh, geez, 4 times 18 plus 12. 4 times 18 plus 12. I got 84. We're going to say 84 units. I think that's the end. Yeah. All right, you survived. Good job.